everyone, today we'll talk about the solution to the problem N-ary Tree Postorder Traversal. So this is the same problem as yesterday, but in this case the tree is not just a binary tree with left and right pointers, but instead an N-ary tree where we have a list of children from left to right and their number can be different than 2. And again we want to provide the easy recursive solution, the follow-up iterative solution. And so if you're unfamiliar with the solution to yesterday's problem, then you might want to go and watch that video. Because here I'll only talk about the differences between this approach and the approach in the yesterday's video. So how to change from binary tree to this arbitrary tree. So in the first solution here we had two lines, go root left and go root right. And now we want to go over everything in root.children, so we can map go over root children, and if we just wrote map go over root children, then this will never execute anything because map is just a generator that will need to ask for consecutive values to get them. So we can, for instance, convert it to a list so that it eagerly executes all the operations. So that's one way of just running the function go over all the children and discarding the results. And likewise in the iterative solution, well, it might seem that, okay, now we have more children, so maybe there's more complicated control flow, maybe we return to the original function multiple times, but it's not true. Since here we had two lines, and we just remembered if we're above those two lines or below those two lines, well, here this is a single line that goes over all the children. And again, there are only two states we can be in. We can be visiting the node for the first time, in which case we have to remember to visit it again and push all the consecutive nodes, all the children to the stack. Or of course, if it's the second visit, we can finally append the value to the result. So again, here we first append ourselves to the stack marked that already our children have been processed. And also we now have to append our children to the stack. So again, we take our children. Again, we have to reverse them because we're pushing them on the stack. So we want the last one that we push to be the first one that's processed. So that would have to be like our leftmost child. So we have to reverse the order of children. And what do we do for every child? Well, if that child is node, we want to append to our stack that node with the mark that it was not processed yet. So we can do it easily with a lambda function. We map it. Again, we use list map in order to force eager execution, force that map to actually execute that function immediately at this point, and at the end we can still return the result. So the changes in this approach were really minute, and so it's pretty robust for this change of adding more children or just changing the number of children, because the solution is essentially the same.